Hello friends, welcome back to the bench. Our patient is this beautiful Alienware gaming laptop with i9 CPU. Looks awesome. Now, what's wrong with it? We're gonna do it in two parts and I'll tell you why in a second. But first in this part, we're just gonna diagnose it and form a plan for actually fixing it. But there are a few things that I gotta learn before we actually do that. So the laptop suffers from slow charging. Now, as you can see, it right now it doesn't really say anymore. Maybe it'll say in a second, but it's at 97% charged, and it says about 3 hours left to fully charged. So obviously it's charging really slowly. The customer states extremely, there you go, 2 hours and 40 minutes to charge 3%. Well, obviously there's a problem. Extremely slow charging, 30% every 24 hours. Yeah, it sucks. When gaming, laptop throttles power to 45 watts and blinks error code on power button. Replaced battery and the DC in adapter, and no change. So typically what happens when this happens? Number one is the adapter, the DC adapter. Let's see if it works off of battery. It looks like it works off of battery just fine. So the discharge is good. We could start some game and see if it also throttles to 45 watts. Now let's get the scope. This is our adapter plug, right? So we see the little pin inside, and the positive is actually the inside of this tube. The outside is negative, and that little pin, that's called ID pin. That ID pin actually communicates with the SAM chip, identifying the charger. The charger needs to be identified because this laptop and gaming laptops in general, or powerful laptops, need to pull a lot of power basically. So they need to be aware what is the maximum power that the brick can deliver and the rating of the cable. That's why on USB-C it's discouraged to use extension cords. They will work for the most part, but the rating of the extension can be different than the charger, and the charger will still identify to the computer that I can deliver 95 watts, right? But the extension can only pull 45, right? And that can be a fire hazard. So issue number one, let me actually show you that. I should be able to show you. Estimated time remaining 2.5 hours. That sounds okay. Let's give it 19.5 volts. Okay. Now it's not saying that it's charging, right? It is pulling 38 watts, roughly 40 watts, but it is not charging, right? That is because we're using just power, no ID pin. I mean, ID pin is technically in there, the pin itself is there, but it doesn't talk to the computer. When you boot the computer from such cable, then the BIOS right away will tell you that the charger cannot be identified, so there's going to be no charging. The battery is not going to be charging. So you can still use the computer. It will throttle down to, whatever, maybe 45 watts, but it will not charge the battery. So that's the problem number one. But that problem has been eliminated by the customer because the charger has been replaced, and that produced no effect. In addition, when you go into BIOS, and actually let's do that. Unfortunately, the HDMI doesn't work in BIOS, so we're gonna have to do it this way. So in BIOS we have a power tab. If we click on the power tab, we have battery configuration. So default is standard, fully charges the battery at standard rate. You can switch that to express charge, the primary AC use, or adaptive, or custom. And if it's switched to primary AC use, then the battery will charge as it is right now. But this option is not selected. Now the laptop is overheating. Can you hear it? Yeah, it went crazy now in BIOS. That's not typical. That's not supposed to happen. The battery health is excellent, the battery state is charging, and the battery level is 94. So this is curious. I cannot see the temperature, but the battery state says charging, right? The adapter has been identified as 330 watt adapter, which is correct. And we jumped from 94 to 95. But the fans are on full spin. The air blowing out of it is hot to the touch. It's burning. So it's got to be over 60 degrees. Way over 60 degrees. So the CPU is probably at 80, 90 degrees. That's way too high. In BIOS, that's crazy. But is it actually the CPU that is producing all that heat? It could be GPU. I mean, it's in one chip, but still, I don't know. This is unexpected. Because here's what I was gonna do. Since we have charging issues, but not powering issues, right? The computer is powered on properly, I mean other than throttling, but so my suspicion immediately goes to SAM chip. SAM chip is a chip that is responsible for talking to the battery and talking to the system. It talks to the battery over SM bus, which is basically I squared C. There's no other than the frequency is supported. There's pretty much no difference. It's regular I squared C communication, and communicates with PCH or EC or CPU or all three, and with SPI bus, right? And so the system itself doesn't have the access to the SAM chips and thus to the battery. SAM chip has access to the battery and it communicates with the rest of the system. So issues around charging usually are going to revolve around SAM chip. That's why I'm not going to be fixing it right now, because I don't even know where the SAM chip is located on this board. So first I need to do a little bit of research before we actually fix this one. But now I'm thinking something else is the problem. Why do I think something else is the problem? Because it's overheating in the BIOS. It's spinning the fans like crazy. It's not supposed to be heating up in BIOS like this. So something else is wrong. It sounds like it's pulling, you know, some modern game. It's already disassembled, but I don't know if the back comes off or the keyboard comes off. Let's try this. First, let's turn it off. Crazy. Crazy how loud it got. But it doesn't get that loud when you boot to Windows. That's kind of unusual. Yeah, I think this back cover comes off. Yeah, all the screws are missing. The customer did warn me about that. which works for me because it'll save me some time on this assembly. Oh, there's one screw. Okay, oh, and something fell out of it. That's not good. Something fell out of the laptop. The heat sinks are way too hot. This is clearly overheating. So that charging problem could be unrelated, you know, because, so here's the other thing. How does the battery actually charge? The battery typically operates on around 11-12 volts. Let's see if this one states the voltage. This is 13.2. That is charging, limited charging voltage, right? So maximum charging voltage is 13.2 volts. So how does the computer actually charge the battery? It needs to take that 20 volts from the charger. It needs to drop it to the proper voltage, and that voltage depends on the charge on the battery. As the battery charges, the voltage increases, right? When the battery is completely discharged, the charging voltage might be around 6, maybe 8 volts. As if the battery is almost at 100%, it's going to be somewhere around 13 volts. So for all that to be possible, we need pretty hefty MOSFETs and pretty hefty coils. It can be 1, 2, maybe even 3 coils to charge the battery. Now I can see immediately over here the area that is heating up. Yeah, there are coils underneath this. Everything's really hot. So this will be tough, but okay, I don't know what exactly is overheating because the entire board is heating up significantly and the PCB is actually heating up. So I think something on the other side of this board. Oh, yeah, to the point like all fans are kicking in. Now we got 4 fans in total. All 4 are kicking in and the board is, whoa, too hot to the touch. 77 degrees. That's the temperature of the PCB. Okay, so the charging problem in this case is a symptom. I would say it's a symptom. It's not the actual problem. We're losing energy. Yeah, the PCB and everywhere PCB is heating up. So there's got to be some shorted component. Whoa. Okay, let's turn it off. It's way too hot. Way too hot. So here we have the overheating problem. That is the main issue here. Now, is the SAM chip shorted? It would explain it. I'm not sure, because when you read in the BIOS the state is charging, that means the communication with the SAM chip was initiated. I think it's the MOSFET that the SAM is controlling, maybe. If the SAM is controlling the MOSFET, because it might not. It might control some other driving chip that delivers power, and it just tells it to deliver or not deliver. And there might be a short to ground, which would explain this behavior as well. Well, it looks like we need to disassemble the entire board, dig it out, and inspect it and look for shorts. But so this is why we're going to do it in two parts, because now I need to assess how much work it is going to be and how much am I going to charge for it. Then write the customer whether that price makes sense. All right. I know Sorin does the flat charge per laptop, but he specializes in laptops. I don't. So, you know, it's gonna be a different price. I don't remember how much he charges, like 150 pounds per laptop, something like that. Flat charge. Was it 150 or was it 50 pounds even? I don't know. Some very fair price, right? But he specializes in laptops. He does only laptops, so obviously, you know, he can be pretty proficient with those. I'm a little less so, but it's definitely an overheating problem, which is curious because it doesn't happen in Windows. In Windows, it doesn't overheat. It only overheats in BIOS. Isn't that crazy? I will also do maybe a little more testing around that, maybe. But yeah, first I need to see if I can get some board views or schematics, which probably I will not be able to get. So we'll see about that. But if I do, that would make it a lot easier because I would know what I'm looking for, and what I'm looking at. Alrighty, so we're gonna terminate it here. We're gonna contact the customer. Well, actually, I'm gonna spend a little more time today on it. It's nice Sunday, so I can spend some time on this. And then we're gonna call the customer and see if we can go ahead and fix this. Because maybe the SAM needs to be replaced, but maybe we'll get lucky and find some shorted MOSFET. In fact, since we already have this area over here, let's hang on, honey. Let's check the cap over here for shorts. Yeah, this is good, or at least no short. Oh, and we have 5.5 ohms here. What is this? It's a little low. Oh, I mean, this could be normal. So we have those caps over here, right? Solid state cap. And this is some kind of rail over here, right? And it could be supplying CPU, which would explain low resistance. It's about 5.9 ohms. So that's low, but that's not a dead short, right? It might be supplying CPU over here, this line. As long as we don't see 0 on anything, it's good. There we have nothing. And here nothing. Yeah. But just, you know, blindly checking that. Well, sometimes you're lucky. Sometimes the first cap you measure, and that's your short. It happens. But I'm not sure if this is gonna be a shorted cap. But it's definitely something on the other side. Well, CPU is on the other side. That's definitely gonna heat up. Underneath this, you can see a little bit over here. That's the coil. So this could be a V-core coils, this could be charging coils for the battery. Could be. But typically this circuitry is closer to the battery, not close to the CPU. So it would be somewhere closer to here, but I don't see anything here. So it's got to be on the other side. This is Wi-Fi next to it. This thing. So that's definitely not charging circuit. So it's got to be on the other side of the board, which sucks. Yeah, it's a little crooked, but I don't think that's the issue. Yeah, and it could have shifted when my battery popped out. So I don't think this is the issue. Soldering here looks okay. Let's check the pins just in case, because it's best to eliminate the simplest problems first, because if it turns out to be a simple problem, then you get a quick win. The pins are solid. I don't see any damage to the connector, like any deformation or anything like that. So so the other side of the board is what we need. Something on that side is overheating by a lot. But that's the plan. Alright, no fix yet, but we'll get to it, probably. Most likely we'll be able to fix it. Alrighty, thank you guys very much for watching. I do appreciate you. And I shall see you in the next one.